Projectile motion and momentum. So the idea here is that we have a projectile launched at some angle theta with some initial velocity v, and then the idea is that at the top of its flight it explodes into two different particles or two different pieces, and then one particle but the two particles have new kind of different velocities. Key idea here is that momentum is conserved, and that at the top of the flight you only have momentum in the x direction. So after the collision or after the explosion, you may have momentum of this particle or the front particle in this direction, and you may have momentum of that particle, the second particle, in this direction. And the key idea is that this momentum plus this momentum added as vectors has to equal that momentum. Those two momentums have to be equal. So starting off with some of the other main ideas, what we need to do is first calculate velocity in the y direction. To start off with, v0 y direction is v0 times the sine of theta. Vx is equal to v0 cosine of theta. The key idea there is that this is constant. It does not change. This here is going to change over time because of gravity. So if we're doing a problem like this, we want to probably first calculate the time to get to the top. Time to the top is going to be the initial velocity in the y direction divided by g. Once we get to the time, from the time to the top, we can get the range, and I'm going to call it the half range, which is really just the distance that it away from the launch point where the rocket explodes, Vx times this t. I'll call this t right here t1 half. Call this here t1 half. Coming back to here, the idea is that this range this is that range right there. That's how far it's gone when it explodes. Having determined that, the next step is to say that m1 plus m2 Vx, that's before the explosion, has to equal m1, what I'll call v1 prime, plus m2 v2 prime, and I'm going to put x here. These are both in the x direction. If there was velocity in the y direction, we would have to write a similar equation, but for most of our problems, there's not going to be velocity in the y direction. So I can get the range, I'm going to call it r prime, for particle 1 is going to be that same time, that t1 half, times v1x, and r2 prime is going to be t1 half v2x, because we know that the particle takes the same amount of time to go up, the time to go up and the time to go back down again are the same, because we were assuming that there's no velocity in the y direction. So that's how we would address the problem related to projectile motion.